Hello and welcome to the main course. Dish up some food for thought. We regularly hear how important having a healthy balance in our lives is. So today we are playing seesaw to see how center of mass and balancing works. We start off with a strong plank balanced on a propping pole. The plank is not fixed to the prop so it can move around. The brown vertical line indicates the center of mass of the seesaw, while the 10 indicates the mass, let's say 10 kg. Think about it as a point under the object where you need to apply the prop to keep the object balanced and prevent it from tilting one way or the other. If the density of the object is uniform throughout, the center of mass will basically be the center of the volume of the object. When the density is non-uniform, the center of mass would be a weighted average point of the volume, weighted by the density at each point. This concurs with a previous video in which we considered the forces of attraction between, for example, the Moon and the Earth. The center of mass gets pulled closer to denser, heavier parts of an object or system of objects. If we move the seesaw slightly to the side, it will not tilt while some part of the prop still touches on both sides of the center of mass, since the gravitational pull of the Earth on the seesaw is still balanced by the prop. As soon as the seesaw is moved too much, the prop is not directly underneath the center of mass anymore, and the object starts rotating around the propping point. If the propping point is close to the center of mass, the rotation is slow, since only a small part of the gravitational pull on the seesaw is not balanced by the prop. When the propping point moves further away from the center of mass, rotation speed increases. Let's set the prop to always move to underneath the center of mass of the system in order to maintain balance. When we place other objects on the seesaw, they form part of the system and they influence the total mass and center of mass. The red vertical line indicates the center of mass of only the spheres, while the green vertical line indicates the center of mass of the total combined system. If the same object is placed symmetrically around the center of mass, they balance each other out, and the center of mass stays on the same line as before, although it moves slightly higher since more mass is added a bit higher up. As these objects move around in the system, the center of mass adjusts accordingly. When we increase an object's mass by adding more volume, the center of mass is pulled towards the object, since it now plays a bigger role in the weighted average position of the system. Note that the seesaw itself still plays the biggest role since its mass constitutes the largest percentage of the mass of the system. The system's center of mass therefore does not move very far away from the center of mass of the seesaw on its own. Another way for an object to be heavier is when it is denser rather than larger. A denser object is heavier per equivalent volume than a less dense object. A denser object therefore plays a bigger role in the determination of the center of mass of a system. Also note how the mass of the seesaw itself plays a diminishing role in the determination of the center of mass as more mass is added to the system, since the seesaw constitutes a smaller percentage of the total system mass. If any object in the system changes position or mass, the center of mass adjusts accordingly. But as long as the propping pole is situated directly underneath the center of mass, and the angular velocity of the slight to and fro rotation isn't too high, the entire system remains balanced. And if the system contains more and more objects are involved in determining the weighted average position, but the idea remains the same. Our own lives work very much the same. A variety of factors with different levels of importance have different impacts on our lives. The propping point to keep everything balanced is somewhere in between the centers of mass of these factors. But if one factor overshadows the others, the propping point needs to favor this one factor above all the others, or the system will start spiraling rather than remaining balanced.